In this video, we're going to practice graphing quadratics. This is something that you already did in both Algebra 1 and Algebra 2. I just thought it would be a good idea to bring it back to your mind again and also allow us the opportunity to practice identifying those key features we looked at in the last video. All right, here is the first quadratic I have for us to graph. First thing we need to find is the vertex. Okay, so we did this quite a while back in the last unit, but here is our vertex formula. Write that on your paper, h equals negative b over 2a. Okay, let's substitute into that formula. So b is the one in front of x. Here's b, so in the numerator I'll have negative 4. And in the denominator, 2 times a, and remember a is the one that's here in front of the x squared. So negative 4 divided by negative 2 is positive 2. That's the x-coordinate of the vertex. Well, I need the y-coordinate to go with it. So let me substitute in 2 for all of the x's. Negative 2 squared plus 4 times 2 plus 2. Notice right here that that is not negative 2 in parentheses. It's not negative 2 squared. It's negative 2 squared. So I want to leave those separately from one another. And if I type all of that in my calculator, I'm going to get 6. Let me put 6 in there. That's my vertex, 2, 6. So now we have the question, is that vertex a minimum or a maximum? Okay, well that is answered by looking at the sign of A. A here is negative, which means my parabola is going to open downward like this. The vertex is going to be right here. So a point at the top is going to be a maximum. In this case, I'm going to have a maximum because my vertex is opening down. Okay, axis of symmetry. Axis of symmetry, you probably remember, is not an actual line on the graph. That's why we make it dotted. It's just a line that helps us to draw the graph. And the axis of symmetry is a vertical line for all of the parabolas that we are going to do. And that it goes always through the x value of the vertex. Okay, so you remember a vertical line has the form x equals a number, and that number is always going to be the same as this one, which is 2. Okay, so let's put that information on our graph. I've got the vertex at the point 2, 6, which is right here, and I have the axis of symmetry as a dotted line going directly through that point. Okay, so in order to graph the parabola, I'm going to need to do either 2 more points on this side or 2 more points on this side, and then use symmetry to figure out the other ones, because the axis of symmetry cuts the parabola right down the center in half. So if my x value of my vertex is 2, an easy point to pick right next to it is 1. So 1 right here being right next to 2, I'll take 1 and substitute in for all my x's, and let's see what y value that we get. Okay, and remember, just like before, I'm not putting that negative 1 in parentheses. It's going to be negative 1 squared. And when I type that into my calculator, I'm going to get 5. So there's the 0.15. Okay, so let's put that one on there. Here's 1, 5. All right, now let's do another one. Let's look at 0. 0 is an easy one to pick if you can, if it's close enough. So I'll put in 0 for all the x's. Okay, this negative in front of the 0 really doesn't matter, right? Because 0 is not positive or negative. But when I put that in there, this part is going to 0 away, and what I have left is 2. So my next point is 0.02. Okay, so do you remember when x is 0, what special point is this? It's the y-intercept. So I'm going to put a dot on the y-axis, 0, 2. Okay, now I'm going to use my symmetry. If this is the axis of symmetry and it cuts the parabola exactly in half, if I have a point 1 unit away this way, I should have a point 1 unit away that way. And if I have a point 2 units away over here, I should have a point 2 units away over here. And now all I need to do is connect the dots. So I'm going to start down here, draw up, connect the dots, arrows on both ends. So there is my parabola. All right, let's take a minute and analyze that parabola, and let's look at some of its features. Okay, first let's look at domain and range. You remember from what we said before, domain is all the values from the left to the right, always left to right, always smallest to biggest. And this one, it's got understood arrows down here. Desmos doesn't draw arrows for me. Understood arrows there. If it goes from the left all the way forever, because this arrow tells me it's going down and left, and it goes to the right all the way forever, that comes from this arrow because it's going down and to the right. So my domain is going to be negative infinity to positive infinity, or I can abbreviate that with the all real number symbol. All right, now how about range? You remember range was bottom to top. Okay, so lowest that this graph goes, those arrows tell me it's going to negative infinity. And the highest this graph goes, if I go up, it's going to stop right here, which you remember from your vertex. You can look back. The y value of the vertex was 6. Remember, range is the only time we're going to use a y value. For every other interval, we're going to use an x value. So then we ask the question, well, should 6 be included or is 6 not included in our range? And you can see that the graph actually reaches 6 right there. So therefore, it's going to be included. I'm going to put a square bracket on that. Okay, let's look at our intervals where the graph is positive. Okay, you remember positive means above the x-axis. So this one is positive here. And negative means below the x-axis, so it's negative in two places. It's negative here, and it's negative again over here. Well, what are the points where it switches from being positive to negative or negative to positive? Well, that's these values right here. Those are our x-intercepts. Okay, so find our x-intercepts. On the x-axis, y is going to be equal to 0. So I'm going to take my quadratic and I'm going to set it equal to 0. All right, I've already got a setup ready to do that over here. Set it equal to 0. Okay, very often we will not want this a to be negative. I would divide across by -1 because we're used to factoring with a positive value here in front of the x squared. But in this case, this one doesn't factor, so there's no reason to do that. When I'm going to do the quadratic formula, which is what I use when it doesn't factor, it doesn't matter whether this one is positive or negative. Okay, so let's substitute a for -1, b is going to be 4, and c is going to be 2. Okay, substitute that into the quadratic formula. Negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. Okay, now think back to when we did the quadratic formula before. What is the first thing that we're going to type into our calculator? Right, the first thing is the discriminant, this part here that's under the square root. So if I type that into my calculator, I'm going to get 24 over -2. Okay, so 24, is that a perfect square number or not a perfect square number? That's not a perfect square number. So that tells me that my two roots or my two solutions or my two zeros are going to be irrational numbers. They're real because it's positive. It does cross the x-axis twice, but they're irrational. So what I'm going to do is I'm going to type this in my calculator to get a decimal approximation. And I'm going to have to type this 2 separate times, once with the positive 24 and once with the negative 24. And if you're going to type that all into your calculator at the same time, you're going to want to put parentheses around that so that your calculator knows to keep all that together in the numerator. All right, well, I've already typed that in my calculator, and this one works out to be negative 0.45 if I round it, and this one works out to be 4.45 if I round that. So let's put those values back over here. This one is negative 0.45, and this one is positive 4.45. Okay, so my interval where the function is positive, that's where it's above the x-axis, and it goes from negative 0.45 to positive 4.45. Remember that we always go from left to right. We always go smallest to biggest. Okay, now the question is, should we put parentheses on that or should we put brackets? Are those points included or they are not included? Well, the y value at both of these points is 0, and 0 is not positive or negative, so we're going to put parentheses. We are not going to include it in the positive or the negative because its y value is 0. Okay, let's do our negative intervals. All right, this one first because it's on the left. We always go left to right. The farthest left that this graph is going to go is to negative infinity. and it's going to keep staying negative until it gets to negative 0.45. Well, it starts being negative again over here, so I need to union that with this other interval, starting at 4.45 but not including, and then going all the way to positive infinity. Okay, so that might seem weird. This is going down. Why am I going to positive infinity? Well, remember, these are x values. We always use x values in our intervals. And as I look at the x-axis, I am going down, but that's a y idea. I'm going to the right. That's the x part. So that's why it's positive infinity, because I'm going to the right. Okay, now let's look at intervals of increasing and decreasing. So let me erase what I have here, and we'll come back and do increasing and decreasing. So increasing. This graph is increasing right here. Increasing means going up. And the graph is decreasing on this side. Decreasing means going down. So the point where it changes from increasing to decreasing is at the vertex. That's right here at the maximum. So remember, when we do intervals, we always use x values. So this time I'm going to use the x value of the vertex in order to write my intervals. Okay, so let's do increasing first. This one is increasing right here, always left to right, always smallest to biggest. So it's increasing from negative infinity, because that's the furthest to the left, up through 2. Now remember, we don't include 2 because actually at 2, it's neither increasing nor decreasing, it's changing. And then we're going to go for the decreasing. It's going to start at 2, but not including 2, because at 2, it is neither increasing nor decreasing. And it's going to go up through positive infinity. And again, the positive infinity because it's going to the right, not because it's going down. We look at these x values, which go left to right, not the y values. Okay, so there are our special key features of this graph. Okay, let's look at one like you're going to see in Delta Math in your homework. So I've got this one, graph this equation, and it says you have to plot 5 points, just like we did before, but this time it tells you the points have to be the roots and the vertex. Okay, so vertex first. You already wrote this formula on your paper. H equals negative b over 2a. All right, so just like before, this one is going to work out to be positive 2. So let's see what happens. Let's put that in our calculators. When I substitute in that 2 for x, and remember that I am not putting parentheses because that's not a negative 2 that I'm trying to square. I'm trying to square 2 and then make it negative. And I get a value of 1. So my vertex is the point 2, 1. Okay, so now it says to find the roots. Do you remember from the last video? What are roots? Well, roots or zeros are the solutions when you set this equation equal to 0. Well, when I set y equal to 0, what I'm actually finding are the x-intercepts. So this is really asking me to find the x-intercepts. So let's take 0 in place of y. All right, so this one does factor. So I don't really want to work with the negative right there. I'm used to seeing a positive. So I'm just going to divide everything by -1 to make that positive. That's not going to affect where the roots are. Okay, so now let's factor this. I got A, B, and C. A is 1, B is -4, C is 3. So A times C, 1 times 3 is 3. So I need two numbers that multiply to 3 and add to be -4. And that's going to be -3 and -1. All right, so let's factor this. I'm going to take out a -1 right there so that they'll match. All right, and then remember when we're solving, we have to take each of those and set them equal to 0. All right, I know the y value of both of those is 0 because that's how I set it up. And now I'm going to put 0 in for my x's, and I'm going to find the y-intercept of 0, -3. Okay, let's look at that on Delta Math. I've already got those points for us, but it asked me for 5. So I'm going to use symmetry to find the 5th one that's over here, and then I'm ready to submit my answer. You can just use symmetry to find that 5th point.